Fun with Application of the Derivative by Sydney Isaacs and Sarah Leibowitz. For our project, we were given question 5, which is a graph of the derivative of f of x. The figure above shows the graph of f prime of x, the derivative of a function f. The domain of f is the set of all real numbers x such that -3 is less than x, which is less than 5. First, we want to find all of the relative maximums of f, and we want to explain why. So first, we draw the f prime of x number line. So we note that the maxes and mins of f of x is equal to the roots on f prime of x. So note the roots: -2, 1, and 4. We then plot those points onto the number line. And look at the top of the x-axis and the bottom of the x-axis to see whether it is positive or negative. Going back to our number line, we see that before -2, f prime of x is positive. From -2 to 1, we see that f prime of x is negative. And again, it's negative between 1 and 4, and then positive 4 on. Here we get our max and mins for f of x. We see that -2 changes from positive to negative, making a max. 1 does not change at all, it stays negative, so it is neither a max nor a min. -4 changes from a negative to a positive, which makes it a relative min. Therefore, now we can answer question A. For what values of x does f have a relative maximum? F has a relative maximum at x equals -2 because the slope changes from positive to negative. We can also answer question B. For what values of x does f have a relative minimum and why? F has a relative minimum at 4 because the slope changes from a negative to a positive. So now we answer C. On what intervals is the graph of f concave upwards? Use f double prime to justify your answer. So we draw the f double prime number line. We need to note that the POIs on f of x is equal to the max and mins of f prime of x. So we note the max and mins of f prime of x on our graph. We see a min at -1, a max at 1, and another minimum at 3. So we plot those points onto our number line. Following the slope of the graph, we see that it is concave down or negative at -1, positive between -1 and 1, which means it is concave upwards, and negative at 1 to 3, which is concave down, and then concave up from 3 on. Here we can note the concavity of our new graph. So now to answer C, we note that it is concave upwards at -1 is less than x, which is less than 1. as well as x is greater than 3. Because the slope is positive. So now to answer D, suppose that f of 1 is equal to 0. We're drawing a sketch that shows the general shape of the graph of the function f on the open interval 0 is less than x is less than 2. But for this purpose, we are drawing -3 is less than x, which is less than 5, and then so now we're answering question D. Suppose that f of 1 is equal to 0. We're making the graph between -3 and 5 so we can show the entire graph, and then making it more inclusive to 0 is less than x, which is less than 2, to answer the question correctly. So first we'll note the maxes and mins on the original f of x graph. We have a max at -2 and a min at 4. Now we have a POI at -1 a POI at 1, and another POI at 3. So now we start drawing our graphs. We note from the f double prime of x that it says concave down up to -1, concave up from 1 to 1, concave down from 1 to 3, and concave up from 3 and on. So now we're going to sketch, as it says before, a graph that's from 0 to x to 0 to x to 2. Now we're marking off the location where it is most important to note the graph. Answering question D, we see that from 0 is less than x, which is less than 2. Here is the most important part of the graph. Answering question D. Thank you. This was our project.